All right, hello everybody. We are going to be moving into the second half of chapter 5, where we're going to be working on actually solving polynomial equations. We're going to look at different ways that we can do that. Today, and in this first section doing that, we're going to be looking at really how do we break them down, and it's going to be a lot of factoring involved in that. As we move further along, then we're going to look at how do we apply things like synthetic division to help us solve, because otherwise we don't have a way to do that. What we're looking at today, you'll often be able to apply some special rules that we'll talk about here in just a moment. The problems down the line don't conform to those special rules or special circumstances, so we got to talk about how do we solve those, but that'll come at a later date. Today, I want to spend some time looking at these different techniques for factoring the polynomials. Run you through this information, look at some examples, and then give you guys a chance to practice as well. So the first thing you should do whenever you need to factor something, and yes, you're going to have to factor in this section, is check for the greatest common factor. That could be a number, that could be a variable, it could be a combo of the two. But always see if you can pull something out, factor it out, to make a simpler problem to solve. Sometimes that'll be the only solving that you can do. Sometimes, though, it'll set you up with a problem that's much easier to do. Smaller numbers to work with, smaller powers to work with. Maybe it creates one of these other scenarios. So always check for that first. Not everything's going to have it, but if you do have it, go ahead and pull it out and use it, because that could be very helpful for you. Then we're going to take a look, and if there's two terms, so two pieces of an equation separated by a subtraction or an addition sign, see if you have any of these three instances. One, do you have a difference of two squares? If you do, so you have two terms, they're perfect, they're each perfect squares, and there's a subtraction sign in between. Take the square root of each term, throw a plus sign in between, throw a minus sign in between them each time you write it, and there you go. You have factored it. You have broken it down into its simplest form, and if these were, say, x's and numbers, you'd be able to start saying the graph crosses the x-axis at this point and this point. That's our whole goal here, ultimately. Now, what we're doing first will be mainly factoring expressions we'll solve on Friday or something like that. All right, so an example of this would be something like this. Say you had 4x squared minus 9y squared. So first of all, notice two terms, minus sign, 4x squared. Is that a perfect square? 9y squared, is that a perfect square? Hopefully now you've answered yes. And so you take the square root of each term. So 2x and 3y. First time you write it, throw a plus in there. Second time you write it, throw a minus in there in between the two terms, and voila, you have now successfully factored a difference of two squares. All right, so now what about a sum? Sum of two cubes. So two terms again, plus sign in between. And both terms are perfect cubes. You can take the cube root of them, add them together, and then you have a second trinomial here. It's one of those instances where you end up with something that might be a little bit simpler to solve when we actually get to the solving. So let's say, for example, we had 8x cubed plus 27y cubed. 8x cubed is a perfect cube. 27y cubed is also a perfect cube. So we're going to break it down. What's the cube root of 8x squared? That's going to be 2x. What's the cube root of 27y cubed? That's going to be 3y. Now, if it's helpful, some people like to write this down. They like to write down what a and b are, since we keep using them throughout the problem. So if we know a is 2x and b is 3y. So that's, cube root of 8x squared, 8x cubed and cube root of 27y cubed. Now we know we add them. Then we take a squared, so 4x squared, remember it's both pieces are squared, minus a times b, so minus 2x times 3y, so minus 6xy, and then plus b squared, so plus 9y squared. Now it's always good to check in these instances to see if we have anything else we can factor. In this case, we can't, so we're done. But this would help lead us to a more solvable equation. Then let's say instead of having a plus sign in between our perfect cubes, we now have a subtraction sign. Notice similar patterns, just instead our signs change a little bit. All right, so let's say we had this time, well, let's just keep the same, almost the same equation. Let's keep it as 8x cubed minus 27y cubed. So we know what a is, and we know what b is. A is 2x, b is 3y. I'm going to make that a little clearer for you guys, sorry. There we go. Now we follow the pattern. A minus b, 2x minus 3y. Then a times a squared, or x squared, plus a times b, so plus 6xy, plus b squared, plus 9y squared. All right. So now we've taken care of there's two terms. If there are three terms in your problem, check and see if you have perfect square trinomials. So in other words, you have an a squared and a b squared on the end. In between is an a and b, and it's doubled. So it would look something like this. Say you had x squared plus 6x plus 9. A is x, b is 3. Perfect square trinomials. Here's your perfect squares on the ends, x squared and 9. What happens if you multiply those two together and multiply them by 2? You have 6x. So, hence we know this is a perfect square trinomial. And we would have, what that means is, this is where you get these double roots. All you have to do is go a plus b quantity squared. So these are creating, you heard reference to it in the one of the last sections about double roots, which means the graph is basically sitting on the x-axis right here at this point because it shows up twice. You can do the same kind of thing down here with a difference in here. So let's say, well, we'll be a little different this time. We'll go x squared minus 10x plus 25. Perfect squares on the ends? You bet. We can say a is x and b is 5. If we multiplied those two together and then multiplied it by 2, would we get, or could we get negative 10x? Yeah, if we multiply by negative 2. So we can say x minus 5, so a minus b quantity squared. So another thing that you can look for to help you solve. Then this is just your general factoring. This is normal factoring. So we're not going to go into a big example like that. We've done that earlier this year. So we use the x. So this would be, we use the x and you have AC, B, then you have AX over a factor of AC, AX over a factor of AC, that whole thing. That's what that's all about. And then the last one down here. If you have 4 or more terms, see if you can group them. Find something in common, some way to group them, and then in that grouping, factor out something. So let's look at an example here. I'm going to write it right here. If we had 8x squared minus 20x, as long as you watch your signs, you can always rearrange things too if you need to. Plus, let's say for some reason you had these separated. Minus 20x plus 6x minus 15. We can group. You say group these first two terms and these second two terms. What's in common between 8x squared and minus 20x? Well, let's pull out 4x. That leaves us with 2x minus 5. Now the goal would be to be able to factor something else out of the second set that creates the same remaining factor. We can do that. We can pull out a 3, and we have 2x minus 5. But we're not done yet, because now we look and we have two terms with a common factor. Now our common factor is that 2x minus 5. So we're going to pull that out. We'll factor it out. And what's left? 4x plus 3. All right, so that's factoring by grouping. And if you need to rearrange, you can. Just watch your signs. Take the right signs with you as you go. Now, one last thing here before I wrap up this video is note that a polynomial that cannot be factored is called a prime polynomial. So you may occasionally run across some of those and you'll just say it's prime and then you're done. All right, so we'll look at a few more hints and some examples here in the next few examples. All right, thank you.